Yes. Yes. Yeah. Hardness of water. Now it is hardness increase. What happens? The impurities increase, hardness increase. It means water is will become very hard water. Very hard water. And also hardness of water. See, water is a very good solvent and even called as a universal solvent. Most of the inorganic salts are soluble in water. The water that has calcium and magnesium salts dissolve in it causes hardness of water. Water passes through rocks and flows on the ground. A soap is sodium salt of higher fatty acid such as stearic acid. See, water is a very good solvent, you know that. Then that's why we call it a universal solvent. Most of the inorganic salts are soluble in water. Yes, the inorganic salts mean sodium chloride, potassium chloride, most of the inorganic salts. They dissolve in water. The water that has calcium and magnesium salt dissolve in it, it causes hardness. So why we will call it hard water? Due to the water contains magnesium, calcium, salts. So this is the reason we call it a hardness of water. So water passes through rocks and flows on the ground. A soap is nothing but a fatty acid, that is stearic acid. Soap in the absence of calcium and magnesium give leather. See, suppose water react with soap, that absence of calcium magnesium ions, it gives leather easily. But in the presence of calcium magnesium react with them and form insoluble soap that appears as a precipitate, that is white color precipitate. So see the reaction. This is the soap. This is the water. If suppose this water contain this calcium magnesium ions, when it react with soap, what happens? We will get insoluble precipitate. That is called scum. So this is the reactions regarding this hardness of water. Now you'll see hardness of water is a, this is a diagram. This is a glass which is contains water and it has calcium, magnesium, iron ion. This is the diagrams, the increasing order of hardness in ppm. So hardness increase, hardness of water is increase. So impurities increase, hardness increase. Say 0 to 425. Let's come to the, when hard water is used for washing purpose, it does not produce lather freely with soap. We know that already because of it has calcium, magnesium salts. Rather, it produces sticky precipitate of calcium and magnesium soap. So, rather it produces sticky precipitate of calcium and magnesium soaps. So instead of it produce lather, it produces precipitate like calcium, magnesium, and the precipitation continues to take place till all calcium and magnesium salt in water are precipitated. So after that, the soap gives lather with water. When all the calcium and magnesium ion is eradicated as precipitate, then after it, the water which is free from calcium, magnesium, salt, that water react with soap and gives lather. So that is the meaning of this word. And next come to the disadvantage of hard water. So water generally we use bathing, cooking, drinking, industrial purpose, and sugar industry, pharmaco industry, and laundry industry, dyeing industry, etc. But in soft water, which you are using there is no problem. Instead of soft water, suppose you are using hard water, you will get problems because of it has salts. That is the main reason. See what happens. Suppose hard water is using for bathing purpose. What happens? Hard water forms sticky precipitate with soap on bath tube and body. So thus cleaning quality of soap is reduced and a lot of its wastage. See, suppose hard water, suppose you are using for bathing purpose, what happened? The cleaning quality of soap is reduced and lot of its wastage. Okay, so that is the reason the soap is wasted due to the hard water. Cooking purpose, what happens? Suppose you use hard water. See, due to the presence of dissolve hardness producing salt, the boiling point of water is elevated. So normal water, that is soft water, it has 100 degrees of boiling point. If salt water is nothing but hard water, the boiling point, of hard water is elevated. So increase due to the salt. Hence, if wanted to boil that water, then what happened? More fuel and time are required for cooking. More fuel is consumption, time is required is very long, and this is the reason the dissolved salts are deposited as carbonates on the inner wall of the utensils. Utensils means instrument, the vessels. So, although the salts are deposited as precipitate on the inner wall of the instrument, that is a utensils. So that is a problem. That is one of the disadvantages of hard water. And now we'll see that drinking. So suppose hard water, suppose you are using drinking purpose, what happens? Hard water causes bad effect on our health due to calcium and magnesium ion present in it, and it forms oxalate crystals in a urinary tract. So it is very dangerous for our health. Now see that textile industries. So what, suppose hard water used in textile industry, what happens? See, one hard water produces precipitates of calcium and magnesium with soap. Calcium and magnesium with soap. The fabrics when dyed later on do not produce exact shade of color. So whatever color we want, we cannot get that color if you use this hard water in textile industry. So exact color we cannot get. Iron and magnesium salt containing water produces colored spots on the fabric, on the cloths. Fabric means cloths. So iron and magnesium salts containing water produces colored spots on the fabric. Now we'll see hard water, suppose used in sugar industry. What is the disadvantage? So waters containing sulfate, nitrates, alkali, carbonates, if you use in sugar refining, okay, sugar refining causes difficulties in the crystallization of sugar. So what is you know that the crystal? What is the structure of crystal? What is the structure of sugar? Crystal, solid. If you are using the hot water, it is difficult to crystallization of sugar. Moreover, the sugar so produced may be deliquescent. Deliquescent means sugar will convert in a liquid state. So that is a big problem. So we cannot, if sugar is converted in liquid state, we cannot transfer from one area to another. We cannot use that sugar. Okay. Next, dyeing industry. See the dissolved calcium and magnesium and iron salt in hard water react with costly dye, forming undesirable precipitate which yield impure shades and give spots on the fabric being dyed. So same problem. If you are using this water, hard water dyeing industry, we cannot get a desirable product. We will get undesirable precipitate. Along with some, you can see that impure shades on that cloths and some spots on the fabric being dyed. So that is a problem of hard water. Suppose you are using in a dyeing industry. Next, laundry. Hard water causes wastage of soap. Iron salt causes coloration of cloths. So next one is pharmaceutical industry. It is very important. If hard water, suppose used in a pharmaceutical industry. So what is mean by pharmaceutical industry? Means in pharmaceutical industry you take biotechnology and Bharat biotechnology. That is one of the pharmaceutical industries. Arabindo, Reddy's Lab. These are the SLNS. These are the pharmaceutical industry. There we prepare drugs, ointment, injection, medicines. In this case, you have to use soft water. But instead of soft water, suppose you are using hot water, what happened? Hmm. Produce whatever product we want to prepare, whatever product we want to make, that is undesirable, that is not appropriate. Because of this drugs and ointment react with them whatever which has impurities like salt, and finally we will get a undesirable product. That is the meaning of pharmaceutical industry. That is a problem we will get in a pharmaceutical industry. Suppose we use hard water. See, hard water if used for the preparation of pharmaceutical products such as drugs, injection, ointment, may produce undesirable products in them. Because of these salts react with the drugs, and finally we will get not appropriate drug. It is undesirable, inappropriate drugs. So that is a problem we'll get in pharmaceutical industry. Next, paper industries. Next we will see paper industry. Iron salts affect the color of the paper. See, iron salt affect the paper of the colors. So the color whatever you have, you know that white color paper. If you are using hard water to prepare the to print the paper, at the time what happens? This iron salt suppose present in water that affect the color of the paper. So that is one of the disadvantage if you are using hard water. So these are the all disadvantages if you are use hard water in the industries. Now we move on types of water. Types of water. So according to chemical reaction, water is classified into two types. So one is hard water, another one is soft water. So you already we have discussed hard water means it contains salts, magnesium, calcium, and soft water which is free from salt, and it is easily reacted with soap, and it is readily give lather. It forms lather with soap readily. So hard water cannot react with soap. Even though it reacts with soap, what happens? It do not give lather readily. So that is a hard water. Uh, Hard water is again classified into two types. There are two types of hard water: permanent hard water and temporary hard water. Permanent hard water, there is no what is classification in the case of soft water. Soft water is drinkable water, mineral water. Soft water is drinkable water and mineral water. Okay, got it. And next, pharmaceutical industry and paper industry we have seen already. This is a diagrams. Water which contains more calcium ions, more magnesium salt, and this is called hard water. This is a water which contains less calcium, magnesium salt. This is called soft water. The appropriate and desirable ions, calcium, magnesium present in water, that is soft water. It's a drinkable water. This water can use in every way. Soft water can use everywhere: commercial, industrial, bathing, cooking, uh, domestic purpose. You can use everywhere, agriculture purpose. Hard water means it has uh, calcium, magnesium concentrations very high. Due to this reason, you cannot use this water bathing, cooking, washing, and agriculture purpose. So this is the difference between hard water and soft water. Now move on to hardness in water is of two types. So, so hard water is classified into two types. That is, you know, the temporary hard water and permanent hard water. See, the temporary hard water is temporary. It is not permanent. So I can easily remove this water by boiling. So suppose calcium and magnesium salt of bicarbonates, especially bicarbonates of calcium, magnesium, suppose present in water, that is temporary hard water. And calcium, magnesium chloride sulfate, nitrate, and carbonate. Suppose present in water, that what is permanent hardness of water. Now you see that what is temporary hardness. Temporary hardness is due to the presence of bicarbonates of calcium and magnesium that can be removed by boiling. Okay, temporary hardness. Why we call it temporary hardness? Because of the presence of bicarbonates of calcium and magnesium. That calcium magnesium can be removed easily by boiling, by heating. On boiling, what happened? Soluble calcium magnesium bicarbonate is converted into insoluble carbonates that can be removed by filtration. See, this is a bicarbonates of calcium magnesium which is present in water. That water is temporary hardness water. Suppose these temporary hard waters boil, heat at appropriate temperature. So what happens? It converts into calcium carbonate, water, and carbon dioxide. See, this carbon dioxide is evaporated into the air. This means weather environment. This how water is remain, and this calcium carbonate is uh, placed in water at the bottom of the place. It is dissolved in water at the bottom of the place because of it is solid particles. That's why it is insoluble solid particles. So bicarbonate is converted into carbonate. This carbonate is insoluble, which is present in water. So like a solid compound. So this bicarbonates can remove by filtrations. Can remove by filtration. So this is the meaning of this reaction. Now see the diagram. This is the water. This water is hard water because of it is contain calcium, magnesium, salt. This is a 20 means that is atomic number of calcium. This magnesium is atomic number of magnesium. Now you see the soap is a sodium salt of higher fatty acid such as stearic acid. Already I said that soap is nothing but a higher fatty acid. Higher fatty acid means this atomic number. What is called that is carbon and hydrogen number is high, and it is fatty acid means it has carbonic acid. Soap is nothing but salt of higher fatty acids such as stearic acid. Soap in the absence of calcium magnesium gives lather. Already I said that with water easily, but in the presence of calcium and magnesium react with them and form insoluble soap that appears as precipitate formation of scum. Formation of scum. This is regarding soap. Yes, soap is a sodium salt of higher fatty acid such as stearic acid. Soap in the absence of calcium and magnesium gives later. Already we have discussed this. In presence of calcium, magnesium react with them and form insoluble soap that appears as a precipitate formation of scum. Scum means it is the one type of precipitate. So let's move on the another slide. That is a permanent hardness. cannot be removed by boiling. So permanent hardness contain calcium chloride, calcium sulfate, and magnesium chloride and magnesium sulfate. These are the salt present in water. That water is permanent hard water. So permanent hard water cannot be removed by boiling. It is due to the salt in water. This salt can be removed by boiling. Cannot be removed by boiling. They are removed by different other methods. uh, that one of the method is reverse osmosis and the ion exchange process. These are the process used to remove permanent hardness of water. See, Fe plus 3, aluminum plus 3 and manganese plus 7 also causes hardness in water, but they are rarely found in hard water. So to remember, next one, to estimate hardness, it is essential to know the various units to measure it. The hardness of water is measured in the terms of calcium carbonate because it is highly insoluble in water and also it is molecular weight is 100 that makes the calculation is easy. So if you wanted to estimate the water, then before you have to know the units of hardness. This is a very important. Suppose you take a 1 liter water, tap water, which is hard water. Cannot use this water for drinking or bathing and commercial and whatever human consumption. So because of salts, it cannot use. So the how much quantity of salt, how much concentration of salt which is present in what we have taken water, you have to estimate. For that, you have to know that units of hardness. So that's why now we'll go on units of hardness. That is first unit hardness is parts per million. Parts per million. See, it is a number of parts of equivalent. That is calcium carbonate per 106 parts of water. For example, 50 ppm hardness means 106 parts of water has 50 parts of equivalent weight. That is the meaning of calcium carbonate. That is meaning of ppm. Next, we will go milligram per liter. That is the number of milligram of equivalent calcium carbonate per liter of water. 1 milligram per liter hardness means 1 milligram of equivalent calcium carbonate per liter of hard water. See, simple 1 ppm is equal 1 milligram per liter. See, 1 kg of water is nothing but 1000 into 1000 milligram is nothing but how much 106 parts of water. So now move on degree class another unit and then last one is degree French. So finally what is the relation? See 1 ppm is equal to 1 milligram per liter is equal to 0.1 French is equal to 0.07 degree Clark. This is a very important relations what it has. And now one hardness of water which is determined by EDTA method. So it involves the complexometry titration. EDTA is a strong complex agent. So ETA means ethylene diamine tetraacetic acid is a strong complexing agent whose structure is given as it is not very soluble in water. Hence, disodium salt of EDA is used in complexometry titrations. So this is a complex look like. So ethylene diamine tetraacetic acid. It is complex. It is insoluble in water. If suppose it is react disodium salt of EDA is soluble in water. So this complex metric is EDTA is nothing but is colorless complex, liquid complex. Use this EDTA and you can determine the hardness of water. Means how much quantity of hardness present in water you can determine easily. So this is a EDTA method. So these are the first unit that is water and its treatment. In this lesson, what we have learned uh, types of hardness and degrees of units of hardness and uses of hardness and a disadvantage of hard water. So this is all about the water and its treatment lesson. Okay, thank you. Thank you so much. Stop.